How do LLMs perform tasks they weren't trained for? Imagine asking a robot to cook a meal it has never seen before. It might surprise you by creating something new using what it already knows. That's similar to how large language models, or LLMs, work when they face tasks they weren't specifically trained for. These models, like ChatGPT, DALL-E, and Midjourney, are built with deep learning, a type of artificial intelligence that uses neural networks to understand language and images. They learn from huge amounts of data, picking up patterns, grammar, facts, and even some reasoning skills. But in real life, they often get asked questions or given tasks that weren't part of their training data. This is where something called out-of-distribution generalization comes into play. It means the models can handle new or unexpected tasks by using what they already know in clever ways. When an LLM encounters a task it has never seen before, it relies on the broad knowledge it learned during pre-training. For example, ChatGPT can answer questions, write stories, or explain ideas it has never seen in its training data because it generalizes from similar examples. This is possible because of how the model's internal structure, especially its attention mechanisms, allows it to combine and recombine learned information flexibly. Think of compositionality as breaking down complex tasks into smaller, familiar parts and then putting them back together to create a new answer. For instance, if asked to write a poem in the style of a famous poet, the model uses its understanding of poetry and that poet's style, even if it was never explicitly trained on that specific combination. Another key factor is the embedding space, which is how the model represents words and sentences as numbers. Research shows that LLMs organize this space in a way that makes it easier to compare and combine different ideas, helping them tackle new tasks. In practice, this means tools like ChatGPT can help with coding, content creation, or customer support without needing retraining for each job. Productivity plugins that use LLMs can summarize emails, draft replies, or generate reports, even if the exact content wasn't in the training data. Image generation models like DALL-E and Midjourney can create visuals based on prompts describing entirely new concepts or styles, not just those seen during training. Of course, these models aren't perfect. Their performance on truly new tasks can vary, and they might produce incorrect or nonsensical answers if the task is too far from their training experience. There's also a risk of bias because the models reflected patterns in their training data, which might include stereotypes or outdated information. Ethically, this raises questions about how reliable these models are and who is responsible if they make mistakes. If used in healthcare, education, or legal fields, errors or biases could have serious consequences. It's important for users to understand what these models can do and where they might fall short. To sum up, large language models are powerful because they can adapt to many different tasks by combining what they've learned in new ways. They don't truly understand or think like humans, but their ability to generalize from their training data makes them useful for a wide range of applications. From writing assistants to image creation, they can do a lot, but always with some limitations and the need for careful oversight.